Check one. Check one. Right. Good evening, everybody. Today, we are going to start off a new series that is Rapid Revision, which was already done for 2022 batch. After that, I didn't do this revision series. And again, this year, I'm doing this revision series for y'all. Today is the introductory session where we'll be revising motion under straight line. Mainly, we'll be focusing on graph section. Before I start, just confirm me from your end. Can you all hear me properly and see the board clearly? Yep. YouTube, Zoom, okay? Mm. Right. Zoom, okay. Yes, right. Right. Perfect. I'll quickly tell you all what is this rapid revision, what is going to happen, and then I'll start the session. Right. Rapid revision. Final 5 months, less than 5 months we have. In this 5 months, if you open up your books, 4 books are there in science. Grade 10 part 1 book, grade 10 part 2 book, grade 11 part 1 book, grade 11 part 2 book. 4 books are there. Altogether 35 lessons are there for you to cover. Now, this revision series is for the students who feel hard to cover the lessons on time and practice questions. If you are a person who has already covered the lessons and doing question, no problem. If you want, you can join the rapid revision. Otherwise, no problem. Just join with the theory class and go ahead. Others, those who are like struck, those who don't know, lot of lessons are there to cover. Plus, questions are there. Those people, the connecting bridge is this rapid revision, where I'll be mainly discussing exam related sections. Now today I'm going to start with physics section, motion in straight line. Under motion in straight line, what most of the students feel hard and what most of the students get low marks is graph section. Mainly graph section. Other than that, you have that velocity calculation, acceleration equal final minus initial velocity, beta. Those things are there. But more than that, the most priority is given to the graph section. Then graph section is where you hit your marks. That section I discuss together with the question. Theory part is very less here because this revision. Theory part is very little here. I would recommend those who are planning to join the rapid revision, best is when I inform you the lesson, go through the lesson already, because once you already did it in the theory. So go through the lesson already so that theory part will be very less. Techniques I will teach you all. Mainly this is techniques. Techniques I will teach you all. How to think to answer a question. Thinking pattern still some students don't know. Now remember, exam is totally different to learning theory, especially when it comes to science and maths. Theory, you learn science. Exam, you show how you think. This is something teacher related. This is something student related. Between that, you should build the bridge. What most of the students do is, for the exam, they learn the theory, and with the theory, they try to do the exam. No, you can't. Parents call us and tell us, sir, full night my daughter stayed and studied the books. But when she goes to the exam, nothing comes into the mind. Of course, yes. Especially science, if you only study the theory and go to the exam, it won't come to the mind. It's a common thing. By now, you should understand. Grade 10 first term, you came across this problem. Grade 10 second term, you came across this problem. Now only one more term is there. So still you can't tell just by studying theory, I am not able to do the exam. Then for exam, what is needed? Exam practices are needed. For that, you need question practice. It's a must. Just think about O-levels. What is O-levels? Think out of the box and see. Is it something that tests your knowledge? Is it truth? No. It is something that tests how much you can remember from what you study. That's it. Hurry, I think I accept. If you are planning, I am a science student, I love science, I want to learn science, therefore I learn science. Hurry. That is correct. But in the last 5 months, your plan should be the exam. For that you work. For that you need question practice together with the main theories. That is what is done in rapid revision. Just only by learning theory, you go to the exam, you can't score. Theory is needed. Important theory section is needed. Together with the important theory section, you need question practice. So that we do in this rapid revision. Thousands of questions are there. Right? Thousands of questions are there for us to discuss. Together with the questions, I will be covering some theory sections as well. Okay. And from your end, what I need is everyone, those who join rapid revision, those who don't join rapid revision, those who join only theory class, not my student, everyone do past papers now. Now is the peak time for you to start the past papers. Don't wait until all the lesson finishes to start the past paper. By the time all the lesson finishes, you can't do all the papers. At least 10 years of paper practice is needed, because at the end of the day, you go and do a paper. You are not, they are not testing your science knowledge. They are testing whether you can do that paper. If you can do the paper, you go to another field. If you can't do the paper, you go into another different field. That is this final O levels. So finally, there is a 4-hour paper for science, 3 hours plus 1 hour. So final end point is a paper. For that, you need paper practice. Weekly, at least one full paper you need to do. Because at the end, you are going to do a paper. You should make paper something common to your eye and your body. Some people, when they see the paper, they faint. Why? No paper practice. Suddenly, when you see in the term test the paper, you faint. That's true, because no paper practice. Every day, make it a habit. Every day, at least weekly, make it a habit to look at a paper. Every subject. It's a must. It's necessary. When something becomes a habit to you, finally, when you face the final exam, it won't become a wonder to you. It's a normal paper thing. So from your end, I need you all to do papers. Start doing the past papers now. Full past papers. If you have, now some people tell, sir, we have done already. Hari, come and do again. Once more do. No problem in it. Now try to score more than the previous one. And your errors, check where you have gone wrong. Recorrect it. Find the theory connection that connects to that error. So those are the things. So from my end, I am starting the rapid revision section. This will be done physically only at Shakthi Institute for Colombo, Shakthi Institute, and others I am doing it online. I don't have any other time slots. So one at Shakthi Institute and other one online. It proceeds online. Hari, what is my story? Hari, without any more talking, I'll start the session. Today I'll not allow unmute feature. Usually my interactive classes I allow the unmute feature. Today I'm not allowing the unmute feature because this is a free link. So many people will be joining. Suddenly if someone unmutes and talks something unnecessary, finish. Whatever the important things, you all send us a message in the chat box. Okay. Hurry. I hope you all have the tute. In case if you don't have the tute, no problem. Use the PDF for now. Use the PDF for now. An important section, write it separately because mainly we focus on questions today. Right. Motion in straight line. Motion in straight line. Actually, why you call this lesson as motion in straight line? Because this lesson is only limited to motions that are going in a straight line. So we are not discussing any circular motions, rotational motions, vibrational motion. No, not that kinds of motion. Here we only discuss about straight line motions. A child walking in north direction, child walking in south direction, a bicycle going in northeast direction. Only straight line. A ball thrown upward, a ball is falling downwards. Straight lines. That's why this lesson is called motion in straight line. You have some equation. Dindingala, I'll write the equation and keep. I hope you all know the equations. I'll write the equations and keep. Number one, you should know how to calculate acceleration. Acceleration is final velocity minus initial velocity divided by time. Even some people write this equation like this. Acceleration is final velocity is given the term v minus initial velocity is given the term u divided by time. Acceleration equal vf minus vi over time or v minus u over time. That is one equation. Now don't think these are two different equations. Both are the same. One equation. Second one, there's an equation like this. Velocity is equal to displacement divided by time. Don't use this. Even though by definition we tell velocity equal rate of change of velocity, rate of change of displacement. And we write the equation v equal d over t. Don't use this equation in your questions. Don't use this. I'll tell the reason when I start doing the graph related questions. Don't use this, but you can use this to tell the definition of velocity. What is velocity? Rate of change of displacement. Rate of change of means, rate of change of something means that something is divided by the time. Whenever when you hear the word rate, remember you divide that physical quantity by the time. So rate of change of displacement means displacement divided by time. So by definition, you can write this equation, but you don't use this equation for any question. Oh, another definition is also there. Velocity is change in displacement per unit time. Change in displacement per unit time. Change in displacement per something means you divide. Change in displacement per unit time means you divide by time. So displacement divide by time. That is second equation. That is used to define what is velocity. That's used to define what is velocity. Next, we have an equation for average speed. Average speed is total distance divided by time. Don't just look and write. Now put it to the mind. Final train for you to catch up these things and memorize and put it to the mind. Average speed is total distance divided by time. Average velocity is same thing. What you do is you take the total displacement divide by time. Those are the main equations. I'll write the units also and keep. Now these things, if you're writing, write with me. Acceleration unit is ms to the power minus 2 meters per square second. Velocity, the unit is ms to the power minus 1 meters per second. Average speed, average velocity also, the unit is meters per second, ms to the power minus 1. Here also meters per second, ms to the power minus 1. Those are the main equations we have. I hope most of you know these equations. What most of the students struggle is graphs. Graphs of motion. Mainly two types of graphs are there for us to discuss. One, velocity time graph. Two, displacement time graph. Velocity time and displacement time. Starting off with velocity time graph. In short form, you call it VT. VT graph. There you go. Y-axis. Y-axis is the velocity axis. Velocity is measured in meters per second. X-axis. X-axis is the time axis. Time is usually measured in seconds. Now that doesn't mean all this should always come in seconds. Some questions they will give it in minutes. Some questions they will give it in hours. Here also. Sometimes velocity will be given in kilometer per hour. Kilometer per hour. kmph. Kmh to the power minus 1. That way also they can give. Right. What are the graphs we have? We have mainly 4 graphs. Number 1. Now look at the graph and decode the nature of the motion. Now this graph, what does this graph tells us? Don't memorize, understand the logic, here. Listen very carefully. See, this is the time axis. Time is going. Harini? Time is going. This is the velocity axis. Velocity is something like speed. Think like speed. Velocity is also increasing. Time is going, velocity increasing. Velocity is something like speed. Now practically think in a car. To increase the speed, what you have to press? To increase the speed, to increase the velocity, what you have to press? If you want to speed up, what you press? Accelerate. So what is happening here? What is the nature of motion here? Acceleration. Acceleration. This is acceleration. This is, there you go, acceleration. But what kind of acceleration? What kind of acceleration? See, I have drawn a straight line. I have drawn a straight line. That means uniformly speed is increasing. Correct term is velocity. Uniformly the velocity is increasing. Uniform acceleration, or even you can tell constant acceleration. Uniform acceleration, constant acceleration. Now you'll ask me, sir, do we have non-uniform acceleration? Yes. Look at this graph. Look at this. See, velocity is increasing. Same like the previous one, somewhat overall velocity is increasing. Acceleration is happening. But is it increasing uniformly? Is the increment uniform? No. This is non-uniform. You press the accelerator, leave it, press it, leave it, press it, leave it. So it's not constant, it's not uniform acceleration, but there is an overall acceleration. We don't discuss about these types of graphs in our syllabus. We won't discuss about it. We only discuss about uniform acceleration graph or constant acceleration graph. So this is constant acceleration. Hinang, with that knowledge, try to decode this. Diago, velocity, meters per second, time in seconds. Upward is constant acceleration. Upward constant acceleration nang downwards, downwards, downwards. Guaranteed deceleration. Doubtlessly, this is deceleration. Another name for deceleration is retardation. Another name is retardation. So guaranteed this is deceleration or retardation. Tell me uniform then non-uniform. Tell me uniform then non-uniform. Or constant or not constant. Uniform. Why? Straight line. I didn't draw it like this. If I draw it like this, non-uniform. No. This is uniform, or you can call it constant. Constant deceleration or constant retardation. Next. See how the graphs are simple. Next. Velocity in meters per second. Time in second. Straight flat line. Straight flat line. Look here carefully. Understand the logic. Straight flat line. Is the velocity increasing? Is the graph going up? Is it increasing? No. Is it decreasing? Is the velocity decreasing? No. Velocity not increasing, velocity not decreasing. That means same velocity. It has the same velocity. Tell me another scientific term for same velocity. Constant. Constant. Constant velocity or uniform velocity. So understand the differences. This is constant acceleration, graph is going up. This is constant deceleration, graph is going down. This is constant velocity, graph is straight flat. Now let's take, I have a ball. I have a ball. I throw it up. From the time the motion starts until the ball comes into my hand back again, what kind of motion is there? From the time ball has started to go up and to come down. First we will analyze it. Ball has started from here. Ball will guaranteed go up in a straight line and come down. That's the motion. Ball will go up and come down. Now think. If you want to throw a ball, initially you should give a velocity. Initially you should give a velocity. There should be a velocity given. See, if I want to throw this pen, I should give a velocity. Then only it goes up. Just if I keep it. Go. Will it go? I should give it a velocity. I should give it a push. So initially there is a velocity. There is a high speed. There is a high velocity. Initially there is a velocity. For sure there is velocity. Now practically think. When it is going up, during the upward motion, when the ball is going up, this velocity will increase or decrease. Practically think, you throw something, velocity increase or decrease until it goes to the top point. Appa, increase. Decrease. Anything, Lamai, if it increases, what will happen? It will increase. You give a small velocity, it will increase the velocity. Velocity means something like speed. It will increase the speed, leave the Earth's atmosphere, leave the space and go to some other planet. Go, throw Atlas pen and see, will it go to another planet? No. It won't. By the time it reaches up, slowly, velocity decrease, speed decreases. If it increases, it should break your roof and it should go up. No, it doesn't happen. You take the phone and throw up. No, it won't go up. It will again come down. Why? Velocity is decreasing. So upward motion until it reaches the top point. This is the maximum height. Until it reaches the maximum height, guaranteed velocity decrease. Velocity decrease means acceleration, the deceleration, deceleration. So this part guaranteed there is deceleration. Guaranteed there's deceleration. If there is acceleration, it should break everything and go up. It won't happen. There is deceleration. Velocity is decreasing. In your terms, if I tell speed is decreasing. Speed decrease. And at the top point, velocity becomes 0. That means at the highest point, the ball will stop. For maybe a millisecond, it will stop. If you want, you throw something and see. Stops. At the top point, it will stop for a millisecond. See? Stops. See? Stops. So for a millisecond, any object that goes up will stop. Why? Deceleration. Let's say you start with a high velocity. When you start with a high velocity, decrease, and guaranteed it should stop. Physics-wise, it should stop. Why? Velocity is decreasing. When velocity decreases, there will be a stopping point. So that stopping point is the maximum height. So at the maximum point, at the maximum height, velocity becomes 0. The object will stop. Now, will it stop and stay there forever? You throw a ball up, you throw a tennis ball up, will it stay in the air forever? No. Again, it will come down. Starting from rest, it is coming down. By the time it comes down, velocity increase. It starts from rest. When it is coming down, velocity slowly increase. Velocity is increasing, acceleration, the deceleration. Guaranteed acceleration. Guaranteed acceleration. And by the time it reaches the initial point, its final velocity and initial velocity will be equal. That means if you throw the ball with 50 meters per second, it will again reach that same point with what speed? 50 meters per second. You throw with 60 meters per second, it will again reach with 60 meters per second. You throw with 100 meters per second, again it will reach with 100 meters per second. Why? Height that it traveled upward, height that it traveled downward are equal. And the acceleration acting on them are equal. What is the acceleration? Gravitational acceleration. That acts as a deceleration here. That acts as an acceleration here. Acceleration is the same. Height is the same. Velocity will be same. You all tell me, if velocities are equal, time taken for upward motion and time taken for downward motion is also what? Velocities are equal, height is equal, acceleration is equal, now times are equal. Time for this motion and time for this motion will be equal. If you want, you take a count and see. You throw something, you take a count and see. For the object to go to the highest point and for the object to come to the lowest point. Times will be equal. On everything together. You have an object, to project it up. First, you should give a initial velocity. When the object is going up, velocity decrease, deceleration. At the maximum height, velocity becomes 0, object comes to rest. Then again it falls down. When the object is falling down, it will accelerate from 0, it comes to a high velocity, acceleration takes place. By the time it reaches the original position, final velocity, initial velocity become equal. Directions are opposite. Previous one upward direction, now downward direction. Directions are opposite, but their magnitudes are same. Time for upward motion, time for downward motion are equal. Oh, now put it to the mind. Now put it to the mind. Object thrown vertically upward. There should be an initial velocity given. While the object is traveling up, deceleration will take place. At the highest point, velocity becomes 0. When the object is falling down, object will accelerate. At the original position, when the object reaches the original position, initial velocity and final velocity become equal. Times are equal. We'll convert it into a graph. Velocity in meters per second. Time in second. Now y'all are going to help me, yeah? This full motion we are going to convert to a graph. Initially, a velocity is given. Initially, a velocity is given. So can I start the graph here at the 0 point? Is it 0 velocity initially? No. Initially, there is a velocity, means somewhere at a higher point I should start. I start the graph somewhere here. During the upward motion, deceleration take place. Deceleration nang, graph should go upward or downward. Using a previous graph knowledge, tell me. Deceleration nang, graph goes up or down? Guaranteed down. Guaranteed graph goes down. So here, deceleration is happening. Deceleration take place. Decelerate, decelerate, decelerate. At the maximum height, velocity become how much? 0. See? Decelerate, decelerate, decelerate. Come to this point. You all tell me, at this point, what's the velocity? 0. That means this is your maximum height point. That is your maximum height point. Why? At maximum height, velocity should become 0. Hari nilamai. At that point, velocity is 0. At that point, velocity is 0. So that is your maximum height. So this is your upward motion graph. Until now, the object have gone only upward. See, started from a high velocity. Deceleration take place. At the highest point, 0 velocity. So this is your upward motion graph. Don't look at the graph and think, graph is going down, that is downward motion. That's not downward motion. This is the upward motion graph. Why? From a high velocity, starting from a high velocity, object is decelerating, object is decelerating. At the maximum point, velocity becomes 0. Can I stop the graph there? No. Again, the object returns down. So I should draw the downward motion graph now. How to draw the downward motion graph? Now, can I draw it in this area itself, A area itself? No. A area is for upward motion. Then where should I draw the downward motion of the graph? B area. I'm taking this as upward motion, then guaranteed downward motion should be B area. Now I should use the B area. Now what is happening there? Downward motion from rest, object is accelerating. Object is accelerating. Again, velocity is increasing. How to draw that? How to draw that? See, the zero velocity, no? From there, object is accelerating. Look mathematically. This is 0. This is minus 10. This is minus 20. Actually, minus means opposite direction. Negative means the opposite direction. Positive means the upward direction. Then negative means the downward direction there. So this negative means the downward direction. Positive means the upward direction, negative means the downward direction. So graph has come in downward direction. In downward direction, 10, 20, velocity is increasing. Harine? Acceleration, velocity increase. In upward motion, velocity decrease 20, 10, 0. In downward motion, velocity increase 0, 10, 20, it will increase. So this way, velocity increase. That's why velocity has come in negative direction. Now, can I draw the graph like this? Some students, they'll draw the graph like this. Is this correct? No. What does this means? What does this means? Ball is going up, decelerating, 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 stopping. Again, it is accelerating upward and going. Again, ball is going up, decelerating, 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 stopping, stopping. Again, going up. Is that what should happen? No. Object should go up, stop, return down. Motion is downward. So the graph should be in the negative direction. So that's why we draw the second part of the graph in the downward negative direction. What can you tell about the times? Here to here the time. Here to here the time should be what? Equal. This timing should be equal. Both those timings should be equal. That is the upward motion. Then this is going to be your downward motion. This will be your downward motion. Here the velocity, let's say you start with 30. You should finish also with how much? You should finish also with 30. Why? Initial velocity, final velocity become equal. Time become equal, initial velocity, final velocity become equal. The gradient becomes same because both the accelerations are the same. So that's your graph. That's your graph. This is acceleration in opposite direction. In opposite direction. That's the acceleration in opposite direction. This deceleration upward, this is at the maximum height, object comes to rest. I'll write it and keep. Object comes to rest. And this in downward direction, acceleration. So you throw a ball up, this is how the graph will be. Deceleration, maximum velocity 0, acceleration. Those are your VT graphs. Again, one more time, tell me. VT graph. Graph going upward, constant acceleration. Graph going downward, constant deceleration. Flat line, constant velocity. Object thrown up, you draw the graph downwards. Again, one more time. Now, put it to the mind. Graph going up, constant acceleration. Graph going down, constant deceleration. Straight flat line, constant velocity. Object thrown up, Graph goes like this. That's your VT graph, velocity time graph. In the tute, those graphs are given. Velocity time graph, constant velocity, constant acceleration, constant deceleration. Here they have not mentioned object thrown up, but the nature of motion is described. Constant deceleration to rest, then constant acceleration in opposite direction. On top of it, just write and keep object thrown up. Object thrown up. Hurry. Now look at this graph. It's mentioned speed, it's velocity. It's the same thing. Even if they mention speed, it's the same thing they are talking about. Velocity. Velocity time graph is given. Analyze the graph. Graph is going up, flat line. Graph is going up, down. Hurry. Work with me. Movement in A. Tell me what is happening in A. Straight flat line up. Straight flat line up means constant acceleration. Don't just write acceleration. Constant acceleration. Constant acceleration. Movement in B, movement in C, movement in D. Right. Movement in B, straight flat line. Constant velocity. Movement in B, constant velocity. Movement in C, this part. Again what? Movement in C. Again constant acceleration. Always straight flat line up is constant acceleration for VT graph. Constant acceleration. You can even mention it as uniform acceleration. That doesn't make a change. Motion in D. Flat line down. Straight line down. Constant deceleration or constant retardation. Constant deceleration. Next, two more things. Gradient under velocity time graph. What does gradient under velocity time graph tells us? On velocity time. Velocity in meters per second. Time in second. I'll take a graph like this. Gradient. What does the gradient gives us? What does the gradient gives us? What is gradient? Tell me. Gradient is difference in the y-axis divided by difference in the x-axis. That is gradient. Mathematically, no. Difference in y-axis divided by difference in x-axis is gradient. Now, in velocity time graph, I'll take y-axis. Y-axis is velocity axis. I'll take two velocity points. Two velocity points. This I'll take as velocity 1 at time 1. This I'll take as velocity 2 at time 2. A initial velocity, a final velocity, and difference in time is there. Gradient is y2 minus y1 over x2 minus x1. Y-axis is velocity axis. Velocity, I have v2, final velocity, minus v1, initial velocity, divided by x-axis, I have time, t2, time, minus t1, time. Now tell me, Final velocity minus initial velocity divided by time. What does it tells us? Final velocity minus initial velocity divided by time. What is it giving us? Final velocity minus initial velocity divided by time. What does it give? Final velocity minus initial velocity divided by time. And what does it give? Acceleration. Final velocity minus initial velocity gives us acceleration. That means I can tell gradient of velocity time graph gives us acceleration. Agree? Gradient of velocity time graph gives us acceleration. Harinila, what is gradient? Difference in y-axis divided by difference in x-axis. Difference in y-axis kiyanne difference in velocity divided by difference in x-axis means difference in time. Difference in velocity divided by difference in time is acceleration. So gradient of velocity time graph gives us acceleration. Put it in the mind. Gradient of velocity time graph gives us acceleration. One more time. Gradient of velocity time graph gives us acceleration. And additionally, velocity time graph, area under the graph. This is the area. Area under the graph will give us the displacement. Gradient gives us acceleration. Area gives us displacement. It's like this. Now we are discussing about velocity time graph. Y-axis is velocity, the main picture is velocity. Velocity time graph. Remember, gradient, mathematically, gradient will always increase a physical quantity by one step. Gradient will increase a quantity by one step. Area will decrease the quantity by one step. Gradient increases the quantity, area decreases the quantity. Tell me, above velocity, next is what? Above velocity, one step above velocity is what? Acceleration. So gradient gives us the acceleration. One step below velocity, it is what? Displacement. Area gives us displacement. See? Displacement, you divide by time, you get velocity. Velocity you divide by time, you get acceleration. So these are one step above. Displacement, you divide by time, velocity. Velocity, you divide by time, acceleration. So above velocity, acceleration. It's the gradient. Below velocity, displacement. It's the area. Simply memorize it like that. In velocity time graph, gradient gives us acceleration. Area gives us displacement. The gradient of velocity time graph represent gradient gives us acceleration. Acceleration in A. We'll calculate the acceleration in A. Acceleration in A kiyanne lamai only this part. How to calculate acceleration? Acceleration is final velocity minus initial velocity divided by time. Or even you can write Vf minus Vi divided by time. What's the final velocity? Look at A motion. Final velocity is here. That is 15 meters per second. Minus. What is the initial velocity? Initial velocity is here. 0. Divide by time. How much of time is taken here? 10 seconds. Time comes in seconds. Yes. 10 seconds. So if I do the math there, 15 minus 0, 15 divided by 10 is 1.5 ms to the power minus 2. 1.5 meters per square second. 1.5 meters per square second. Harane. Area under velocity time graph represent. Area gives us. Area is one step below. Area under velocity time graph is displacement. Area gives us the displacement. Displacement in A. We'll calculate the displacement in A. Look at A. Look at A. Onnaputa. A is a rectangle. Sorry, A is a triangle. A is a triangle. Only look at this triangle. Base is there 10. Perpendicular height is there how much? 15. From 0, 15. Perpendicular height is there 15. Height is there, base is there. Calculate the area. Now maths. Calculate the area. Area is half into base into height. That is half into base is 10 into height is 15. That is 5 into 15. 5 into 15 is 75. Displacement comes in meters. 75 meters. So displacement is, there you go, 75 meters. Work, work, work. Don't just stay here. No one just staying here. Last 5 months, every second is important. Right. That is velocity time graph. That is velocity time graph. Next going to displacement time graph. Next going to displacement time graph. Well, my displacement, the symbol is S. That's a standard symbol for displacement. And time is T, is called ST graph. That's why some books you would have seen ST graph. Some old syllabus papers you would have seen ST graph. S is the symbol for displacement. ST graph. Huh? What are the graphs we have? Try to decode. On displacement time graph, displacement in meters, time in seconds. Now think, eh? Now think very carefully. Graph is going up. Penna, don't tell me it's acceleration. No, not acceleration. Think. See, time is going. Time is going. This is displacement. Displacement is something like distance. Put in the mind something. It's something like distance. Displacement is increasing. Time is going, displacement is increasing. Displacement is increasing. Displacement is something like distance. Time is going, displacement is increasing. Displacement is increasing. That means there is a velocity. Velocity is speed, no? There's a velocity. See, time is going, displacement is increasing means there is a velocity. What kind of velocity is there? Straight line. What kind of velocity? Straight line. What kind of velocity? Constant. There is a constant velocity. Time is going, displacement is increasing, means there is a velocity. It's a straight line, constant velocity. So this is constant velocity. Don't get confused with VT graph and ST graph. VT graph, straight flat line up is constant acceleration. ST graph, straight flat line up is constant velocity. Number two. එහෙනම් what is this? What is that? Hmm? Deceleration? No. I told you can still talk about deceleration. Straight flat line up is constant velocity. එහෙනම් straight flat line down is. Now think logically. Think logically. See, time is going. Displacement is increasing or decreasing? Displacement is decreasing. That means vehicle is going forward or vehicle is going reverse. Displacement decrease means vehicle is going forward or it's going reverse, it's going backwards. Backwards. Previous one, time was going, displacement was increasing, vehicle was moving forward. Now time is going, vehicle is, displacement is decreasing, means vehicle is reversing. There is reversing. How it is reversing? With a velocity. Harine, you have to reverse with a speed. There should be a speed. So there is a velocity. There is a velocity. There is a velocity. Straight flat line. There is a constant velocity. There is a constant velocity. But that constant velocity is in the forward direction or backward direction? Backward. That means you can tell it's in the opposite direction. It's in the opposite direction. Previous one, just constant velocity. Maybe it's forward direction. It's in a positive direction. This same constant velocity, but in opposite direction. The same constant velocity, opposite direction. If I define the motion, if I put both into one graph and define the motion, ST graph, A part, vehicle is moving forward, B part, vehicle is moving backwards. And both have come to the same starting point. Understood? A part, vehicle is moving forward with the same speed. Same velocity. B part, vehicle is moving backward with the same velocity. No acceleration, no deceleration. Acceleration means speed should increase. No, speed is not increasing. Speed is the same. I'm not increasing the speed, no. It's the same speed. It's the same velocity. Moving forward, moving backwards. If it is acceleration, it will go like this. That's acceleration. No. It's the same velocity, constant velocity. But motion is in forward direction and backward direction. That's the only difference. Sir, you won't get sugar. Yes. The amount of walking, I won't get sugar. Harine? Hmm? So don't get confused. ST graph, this is forward kiyanne a positive direction constant velocity. This is opposite direction constant velocity. Right. ST graph. Hmm. What is that? Hmm? What is that? See, time is going. Time is going. Displacement is something like distance. Displacement, is it increasing? Is it decreasing? No. Displacement not increasing, not decreasing. That means object at rest. This is object at rest. That's the object at rest. Now see, eh? Displacement time. What is that? Mhm. Curved. Think like this. Look at the start. Start is flat. Can you see? There is a flat line at the start. There is a flat line at the start. End, there is a vertical line. See, end, it's vertical. End is vertical. Start is flat line. End is vertical. Start is flat line. Flat line means what? Rest. So initially, object is at rest, no doubt. Initially, it's at rest. But towards the end, flat line up, straight flat line up, straight flat line up means, straight flat line up means there is a high velocity. There is a high velocity. Towards the end, there is a high velocity. There is a high velocity. Now, practically think. Initially rest. Towards the end, high velocity. Velocity is something like speed. Initially 0, rest. But after some time, it's moving at a high velocity. You all tell me, a car, initially at rest. Suddenly you have to bring it to a high velocity. What do you have to press? What do you have to press? Accelerate. So what is this? What is that? Initially at rest, towards the end, high velocity can. This is acceleration. Logically think. Initially at rest, towards the end, high velocity, acceleration. What kind of acceleration? Uniform or non-uniformed? Uniform or non-uniform? Uniform. Why? This curve is very smooth. Smoothly I took. Did I take the curve like this? If I take it like this, non-uniform. No, it's very smooth. Smooth can uniform. Uniform acceleration. That's uniform acceleration. Now your turn, eh? Displacement in meters, time in seconds. Think. Starting what, finishing what? Think starting what, finishing what, and find out what it is. Hmm? Very good. See, starting, there is a vertical line. Starting, a vertical line is there. Towards the end, graph is becoming flat. Towards the end, graph is flat. Starting vertical line, end flat line. Vertical line can there is a high velocity. Flat line can it's coming to rest. You all tell me. From a high velocity to rest. High velocity to rest. What is happening? What is happening? High velocity to rest. Deceleration. High velocity to rest. Deceleration, or even you can call it retardation. What kind of deceleration? Uniform or non-uniform? Uniform. Why? It's a smooth line. uniform. Or even you can use the word constant, it's the same. Okay. One more time. ST graph, displacement time graph. Straight flat line up, uniform velocity. Straight flat line down, uniform velocity in opposite direction. Flat line, object at rest. Flat to vertical, flat to vertical, flat to vertical, uniform acceleration. Vertical to flat, uniform deceleration. Again, one more time, open the mouth and tell, now which of you memorize. ST graph, straight flat line up, uniform velocity. Straight flat line down, uniform velocity in opposite direction. Straight flat line, object at rest. Flat to vertical, flat to vertical, flat to vertical, uniform acceleration. Vertical to flat, uniform deceleration. Clear? Clear? Yes. Crystal clear, super clear. Yes. YouTube. Crystal clear. Perfect. Then only one more thing is there. Y'all think and tell me. Displacement time, gradient, one step higher. What is one step higher of displacement? Gradient is one step higher. What is one step higher? Don't go 2-3 steps higher. All of my thing. At once you all are jumping 2-3 staircase. Don't do like that. One by one we'll go. One step higher. What is one step higher than displacement? Velocity. Gradient gives us velocity. Harini, gradient is y divided by x. Y is displacement, x is time. Displacement over time is velocity. Displacement over time is velocity. By definition, it's velocity. I told you, don't use this in equation. By definition, displacement divided by time is velocity. Area. What does the area gives us? One step lower. What does the area gives us? One step lower. Hmm? What does the area gives us? Remember, area of displacement time graph gives us nothing. Nothing. Nothing is represented by the area. Harinilamai, is there anything below displacement? No, no. Displacement and distance are almost the same. Don't tell distance. Below displacement, nothing. So area gives us nothing. You calculate the area, it gives us nothing, no data. Only gradient of velocity, displacement time graph gives us velocity. Previous one, velocity time graph, both gives us two things. See, here, gradient gives acceleration, area gives displacement. Here, gradient gives one step higher velocity, area one step lower, nothing. It gives nothing. Okay. Huh. Those graphs are given for a stationary body, object at rest. Body moving with constant velocity, graph is given. Body moving with constant acceleration, graph is given. Body moving with constant retardation, graph is given. Gradient of displacement time graph represent. Gradient represents us what? Gradient gives us velocity. Okay, no? Hurry. We'll solve some problems. Take question 1. Now do, eh? Now is the time where you work. Until now I was working. Now it's the time for you to work. 100% you should give yourself. Don't think, theory is done. Appa, I'm very tired. We'll sit and watch. No. No sitting and watching. You have to work. Take a paper together with me, work. You're solving all these questions. Otherwise, no point. No point sitting all this 1 hour. Right. Question 1. All read. Read it yourself. Particular vehicle was moving in a straight line. The driver saw a child who tried to cross the road just ahead of the vehicle. The driver suddenly applied the brake to stop the vehicle. Now look at the graph. There's a vehicle traveling in Vaya road. Right. Suddenly a Range Rover came. Driver is applying brake. If there's no brake, no point. Right? Bus will turn upside down and fall about 1,000 feet down if there's no brake. But luckily, I think this fellow has brakes. Particular vehicle, no. Not the Sri Lankan usual buses. Right? So this is a particular vehicle, maybe a good vehicle. So he is applying brake. Now when he applies brake, guaranteed vehicle will decelerate, which means this part is the braking part. There he is applying brake. His legs are on the brake. Now when you are driving Lamai, the moment you see something, you can't apply the brake. There will be a small reaction time. Even though you saw, it takes a bit of a time for you to keep the leg and break it. That's called the reaction time. You should try maximum to reduce your reaction time in any activity. Now, usually Formula 1 races, their reaction time is very short. They have very small reaction time. Quickly they can respond to something. Right? Now, when you get older, your reaction time reduces. Your reaction time increases, sorry. That means you take a long time to react to something. Someone comes and tells you, this person passed away. So it takes a long time. So that is longer reaction time. So here, now this fellow, for this much of time, how much of time? 0.5 second. 0.5 second, he didn't still apply the brake. After that only he's applying the brake. Up to here, no brake. See, there's a constant velocity. And then only braking is taking place, right? So first you should understand the graph and the story that they are telling. The following graph shows the VT graph of the above mentioned vehicle. The time that the driver saw the vehicle as taken as T0. At T0, he has seen the child. So he has seen the child here. It's a nice question. See, so many things are there to analyze. So at T0, he has seen the child. And he is taking 0.5 second to apply the brake. 0.5 second means such a long reaction time. It's kind of a long reaction time. So this much of time for him to react, then he's applying brake. Or maybe he's applying brake, but vehicle brake is taking 0.5 seconds to work. That also may be an issue. Right. Question A. What is the distance the vehicle travel from T node until the brake is applied? What is the distance the vehicle travel from T node until the brake is applied? That means which part of the graph they are talking. From T node until the brake is applied. Until the brake is applied, how much of distance the vehicle is traveling? That's the question. Now see, this is T node. Brake is applied here. So from here to there is a distance the vehicle covering. This point only, that person is applying brake. So here to there is a time that the brakes are not applied. Vehicle is moving. So there is a distance that the vehicle is covering this part. They're asking that distance. Or fine. What's the graph? VT graph. Go find out. VT graph, how do you find the distance? Area under the graph. You think apply the equation and find out. That's a rectangle. 2.5. 2.5. Question 1A. It's a rectangle. 0.5 seconds. This is 2 ms to the power minus 1. Need 2.5. Find the area. Work, work, work. Don't just stay. Area is equal to, this is a rectangle, length into breadth. That is 2 into 0.5. Half of 2 is 1 meter. Half of 2 is 1 meter. So there the time taken is 1 meter. Don't just write 1 meter and keep, write with the working. Now is the time for you to work. B part. What is the deceleration of the vehicle occurred by applying brake? Mention the unit as well. Now you should identify the braking time period. Braking time period is, I'll color it with a different color. This is the braking time period. During that time period, they're asking what's the deceleration. They're asking what's the deceleration. What are the data I have? I have the initial velocity. Initial velocity is 2 meters per second. I have the final velocity. Final velocity 4 kiyanne velocity is here. Final velocity is 0. 0. Tell me what is the braking time? How much of time taken for the brake? Braking time is what? Full time is 4 seconds. 0.5 second is reaction time. Then what is the braking time? Full time 4, reaction time 0.5 and braking time is only 3.5 seconds. Final velocity I have, initial velocity I have, braking time I have. Now find the deceleration. I mean, remember, we don't have any equation to directly calculate deceleration. What we calculate is acceleration. But if the acceleration is a negative value, that is called deceleration. If the acceleration is negative value, you call it deceleration. So I'll find the acceleration. Acceleration is final velocity minus initial velocity divided by time. Final velocity is 0. Initial velocity is 2. Final velocity is 0. Initial velocity is 2 ms to the power minus 1. And the time taken, don't tell 4 seconds. Full time is only 4 seconds. Reaction time is there. Reaction time is 0.5. So already 0.5 gone. Remaining is 3.5. So braking time is 3.5 seconds. So if I do the math, 0 minus 2 is minus 2 ms to the power minus 1 divided by 3.5 seconds. That gives us 0.5 something. 0.57. Yes. 0.57 positive the negative. Positive or negative? Negative. Minus 0.57 ms to the power minus 2. This is acceleration. They are not asking acceleration. They are asking deceleration. Remember, when you get a negative acceleration, you can write it as a positive deceleration. You can directly write 0.57 ms to the power minus 2. See, I calculated the acceleration. I am getting a negative acceleration. I can write it as a positive deceleration. Again, I repeat, I calculated acceleration. I am getting a negative acceleration. I can write it as a positive deceleration. So how did you divide? Now you jump a decimal and divide. 2 divided by 3.5. Don't tell you can't divide this. How to divide? You can do like this. Jump a decimal. When you jump a decimal, 20 divided by 35. You can cut it by 5. 4, 7. 4 divided by 7. Then you will get 0.5 something. 0.57. But if we get positive acceleration, that's acceleration. You don't need to again write a deceleration there. If you get positive acceleration, it's directly acceleration. Now here we are calculating deceleration. So what you will get is negative acceleration that we change to positive deceleration. With the unit time, ms to the power minus 2. Hurry. Question 2. Don't just wait. A rubber band is fixed to a 2 kilogram trolley. Right, okay. A horizontal force is applied by stretching the rubber band and it moves along a straight line. Right. There is a trolley. To the trolley, a rubber band is fitted. A horizontal force is applied by stretching the rubber band and it moved along a straight line. So they are stretching the rubber band and maybe they are releasing. So when you stretch the rubber band and release, guaranteed it will accelerate. We'll see what they are telling. Graph shows the velocity time graph for the movement of the application of movement from the moment of application of force to 10 seconds in the movement. Hurry. So what is happening here? When you apply a force using rubber band and release it, guaranteed the trolley will accelerate. So tell me, velocity time graph, this part, what is that part? Straight flat line up. What is it? VT graph up is constant acceleration. So that part is constant acceleration. What about this part? 5 second to 7 second? Constant deceleration. So trolley is decelerating as well. It's accelerating and it is decelerating. This part, 7 seconds to 10 seconds. Constant velocity. Now we'll analyze. They are stretching the rubber band and releasing. When you stretch the rubber band and release it from rest, it will gain a high velocity. Acceleration is taking place. After it reaches to a certain point, it is decelerating, it seems. Maybe due to friction, it can decelerate. Otherwise, there's no need to decelerate. No? The trolley is decelerating maybe due to friction. Because friction is an opposing force for the motion. So there is a part where the trolley is getting an opposing force and it is decelerating maybe because of friction. So this part can be because of friction. And then again it is traveling with the same velocity. Now friction is not there. Maybe a rough surface is not there. Now again smooth surface. So here acceleration. Here may be a rough surface. The trolley is decelerating. Here a smooth surface. It's going in constant velocity. So understand the motion. You stretch the rubber band and release. Trolley is moving with the acceleration. Then due to some reason it's decelerating. Speed is decreasing a little bit and going with the same velocity. Define the term velocity. How do you define velocity? Rate of change of displacement. Or you can write, yes, the change in displacement in unit time. That is also correct. I gave you all both the definitions, no? Rate of change of displacement. Rate of change of displacement or change in displacement in unit time. B question. What is the time it moves with uniform velocity? Tell me where it is moving with uniform velocity. This part. What is the time? What is the time? Now, when they ask what is the time, it's not a very proper answer to tell, just 3 seconds. Properly tell the time. 7 seconds to 10 seconds. 7 seconds to 10 seconds. 7 seconds to 10 seconds. 7 seconds to 10 seconds, which is almost 3 seconds. See Roman 1. How does the trolley move during the time period 5 seconds to 7 seconds? 5 seconds to 7 seconds. 5 seconds to 7 seconds. How is the trolley moving? Constant deceleration. Perfect. Or even you can tell constant retardation is the same. Mention the factor that resulted in the motion you mentioned in Roman 1. What would have caused this constant deceleration? Maybe because of friction. Friction. Or even you can write opposing force. Opposing force. Instead of friction, you can tell opposing force. We don't know what is the opposing force. Something is trying to stop it a little bit. D part. During the time period 7 seconds to 10 seconds. 7 to 10. 7 to 10 is this part. Okay. 7 to 10. I'll box it 10 keep with a different color. This part. 7 second to 10 second. Find the distance travel. Ayyo, lamai. This part. What's the distance? How to find? Velocity time graph. Distance is one step lower. You find the area. Gradient is one step higher. Distance is one step lower. So here you find the area. 7 to 10. 7 to 10. 7 to 10 kiyanne. 7 to 10 kiyanne lamai. What's the gap here? 3. 7 to 10 is 3. And what is the height here? What's the height here? 6. Height is 6. Now find the area. Area is equal to length into breadth. Length is 6, breadth is 3, 18 meters. Isn't the graph questions becoming easier? Hmm. Not hard. Are they O-level questions? Yes, all are O-level questions. All are taken from the past papers. Maybe you would have not come across these past papers. They're very little bit of old ones, but still repeated type of questions. Still recent days you get questions like this. This is a bit of old one, but same type of question comes. Will the same question. I won't tell exact same question they will give you again. Same type of question will come. Same type of question. Lamai. There is a scope in which they can make the paper. No? Now, when they are making a paper, maybe they can give a graph. For the graph, they will give a story. So story is given, a graph is given. And they might ask you, this part of the graph, what is it telling you? And if it is velocity time graph, one they can ask the displacement, one they can ask the acceleration. This part, what it is telling, this part, what it is telling. Maybe they can continue the graph. What does it tell? And they can ask displacement, they can ask the um, um, accelerations. Those are the main things. So the scope of the theory is the same. Only the way the questions asked is different. Hmm. Let's go to the third one. The following graph shows the displacement time graph of a moving bicycle in a straight line. First, look at the graph and analyze. See how easy the questions are when you analyze the graph. What most of the students do is they don't analyze the graph, directly they start the question. We'll analyze the graph. This part, tell me the nature of motion. 0 to A, nature of motion. Displacement time graph, straight flat line up. Constant velocity. This part, just dotted lines are given. Last part. What can you tell? Displacement time graph, straight line down is again constant velocity in the same direction, opposite direction. Opposite direction. Opposite direction. Which means A to B, there is a resting phase. So what has happened is in the bicycle, this person has gone until A, has waited a little bit, turned the bicycle, again gone to the same place. Huh. Question A, describe in brief the motion of the above bicycle. What's the motion of the above bicycle? 0 to 15 second, constant velocity. I'll just write constant velocity. When you all are writing, you can write 0 to 15 second. Bicycle has moved in constant velocity. You can write it that way. Constant velocity. 15 second to 20 second. No, not second. No, it goes in minutes. 15 minutes to 20 minutes at rest. 15 minutes to 20 minutes. Bicycle is at rest. And last part, 20 minutes to 30 minutes, bicycle is moving in constant velocity in opposite direction. 20 minutes to 30 minutes, bicycle is moving in opposite direction. Opposite direction at constant velocity. Okay. B part. What is the displacement of the bicycle during the first 15 minutes? First 15 minutes, what's the displacement? Now, Panna, don't go to find the area. You don't need the area. Why? This is directly displacement time graph. Look at the graph. For velocity time graph only, you find the area. Here, directly displacement time graph is given. 15 minutes. What's the displacement? What's the displacement? 2 kilometers. Don't go to find the area. I told you, area gives us nothing here. If you have found nothing. Don't do it. Displacement time graph. Displacement time graph. Directly gives us the displacement. So first 15 minutes, he has traveled 2 kilometers. I'll directly write it here. 2 kilometers. C part. Calculate the rate of change of displacement. First tell me, what is rate of change of displacement? Previous question we came across this. See, now this is the connection in past papers. What is rate of change of displacement? Velocity. So basically, question is asking us the velocity. Calculate the velocity in kilometers per hour for first 15 minutes. For first 15 minutes. First 15 minutes. Hurry. We'll find the gradient. Velocity, displacement. Displacement in kilometers, time in minutes, 15 minutes, 2 kilometers. We know gradient of displacement time graph gives us velocity. So velocity is gradient. Gradient is difference in the y-axis. Difference in the y-axis here is 2 kilometer. 2 kilometer divided by difference in the x-axis. Difference in the x-axis is 15 minutes. But they are asking in what? They are asking the answer in Lamai kilometer per hour. So can I write it as 15 minutes? Tell me. Can I write it as 15 minutes? No. I can write it 15 minutes. Convert to hours. Tell me. 15 minutes is how many hours? How many hours? 1 hour? Scholarship questions. Quarter of an hour. Quarter of an hour. Quarter of an hour. Or you can tell 0.25. Quarter is 0.25. So I'll write it as 1 over 4 hour. How to do this? Division under division. Division under division. Division under division is what? Multiplication. Division under division is multiplication. I can take this 4 on top. So if I take this 4 on top, 2 multiplied by 4 kilometer per hour. 8 kilometer per hour. Okay. So that is 8 kilometer per hour. Give the term for rate of change of displacement. What is rate of change of displacement? I already wrote it. Rate of change of displacement is velocity. Equation. Sketch the velocity time graph for the above motion of the bicycle. Displacement is given in kilometers. Displacement time graph is given. They are asking you to draw the velocity time graph for this. Try. Give it a try. Try. For this, they are asking velocity time graph. How to convert? This graph, they are asking you the velocity time graph. You did try. How to do? Right. We already analyzed the graph. This part, it's constant velocity. This part is object at rest. This part is again constant velocity, but in the opposite direction. You should show the direction as well. Right. And see, here also you have a velocity, here also you have a velocity. Velocity means something like speed. Where the speed is high, where the velocity is high. First part of the motion or second part of the motion. Don't tell both are same velocity, not same velocity. At one part, object is moving fast. At another part, object is moving slower. Where object is moving fast, a high velocity. One, the two, the where high velocity. How to think? This how you think. See, 2 kilometers is the target. You are given 2 kilometer target. You are going the 2 kilometer taking 15 minutes. But you are coming from that 2 kilometer only taking 10 minutes. You are going 15 minutes. You are coming 10 minutes. Very fast. Second one. See, that's why the graph is very short. Again, gradient is high. The gradient, slope is high. Here, slope is very low. Gradient is low. Velocity is low. Here, gradient is high. If the slope is like this, gradient is very, very high. Then velocity is very high. Right? So remember, when the gradient increases, velocity increase. 15 minutes, 2 kilometer. 10 minutes, 2 kilometer. When coming, is coming fast. You should consider all those things and draw the graph. Hurry. I'll draw the graph. You should draw the VT graph for this. Velocity in kilometer per hour. No. In kilometer, I'll convert to meters. Better. This given in kilometer, this given in minutes, no? Right, we'll do like this. In kilometer per minute. They are not telling any unit, no? Velocity in kilometer per minute. Time in minutes. Or otherwise we can draw for hour as well. Yeah, we'll draw for hour. Kilometer per hour. And time also in hour. Kilometer per hour, time in hour. Right. This part constant velocity. Constant velocity nang in VT graph, how the graph will be. Constant velocity nang in the VT graph, how the graph will be. Constant velocity is lamai this straight flat line. No? Constant velocity is straight flat line. Straight flat line. That's your constant velocity. That's your constant velocity. Now, what's the constant velocity there? What's the constant velocity there? We already calculated. Calculate the rate of change of displacement in kilometer per hour for first 15 minutes. First 15 minutes, what's the constant velocity? 8. 8 kilometer per hour. So this part is 8 kilometer per hour. How much of time is taken for that? 15 minutes. 15 minutes is taken. If you want, you can draw it in hours. Or we can draw it in minutes itself. It's more easy. No conversion. So if I put minutes there, in 15 minutes. Next, for 5 minutes, it's at rest. 5 minutes at rest means where the graph will be in VT graph. At rest means this is your 0 point. So at the 0 point, 5 minutes graph will be flat like that. 5 minutes. Then the total time is 20 minutes. 15 minutes 8 kilometer per hour. 5 minutes speed is 0. Next, constant velocity opposite direction. Opposite direction nang I should draw it in the same positive direction or negative direction. A part of the graph or B part of the graph I should draw the graph. Opposite direction. Think about that ball story I explained. B part of the graph, not in the A part. So the next part of the graph comes in the B part of the graph. Next part of the graph comes to the B part of the graph. How do I draw it? This part will calculate the velocity. Velocity is going to be displacement is same 2 kilometer divided by 10 minutes. Tell me that in hours. 10 minutes. How to convert hours? Divide by 60. 10 minutes divide by 60 is 106. 106. This is kilometer. This is hour. That becomes 2 into 6. 6 goes on top. 2 into 6. 2 into 6 is 12 kilometer per hour. 12 kilometer per hour means this gap should be more now. That is 12. 8 is short. 12 is large. So that gap should be bigger than the previous one. That's the 12 line. So somewhere here, you draw your graph. How much of time? 10 minutes, then 20 to 30 minutes. That will be your graph. So again, look at the graph. This part of the motion is constant velocity, straight flat line. Velocity is 8. How long? 15 minutes. Next, it's at rest. Rest means graph will come here. At rest. How long? 5 minutes. Next, last part. Last part, now the velocity is higher than the previous one. See, in 10 minutes he is traveling 2 kilometers. That means the velocity there is 12 kilometer per hour. 12 kilometer per hour means this gap will be more than the previous one, somewhere here. So here, the last part of the graph. Raise then, if anybody has got this graph. This graph. Understood now how to convert displacement time graph to velocity time graph? How I did the conversion? Clear? These units, you should be careful now. Here, they have played a lot with units. I selected this as kilometer per hour, this as minutes. So the calculations will be easier. Can I connect it? That doesn't make a big difference. Connecting, not connecting doesn't make a big difference. You can connect it, no problem. Okay, now. Come to MCQ question. Which is the correct velocity time graph for the motion of an object thrown vertically downward with an initial velocity? Something falling down. Something falling down with the initial velocity. Object is falling down with initial velocity. What's your graph? First tell me, if an object is falling down, they have thrown it. If an object is falling down, it will accelerate or decelerate. Accelerate or decelerate. Object is falling down. Accelerate or decelerate. Guaranteed accelerate. In a VT graph, how do you draw acceleration? Usually this is how you draw. But here it's thrown with a velocity. If it is thrown with a velocity, you start from somewhere here. Then you draw the graph like that. So what's the best fit graph? Second one. So why not first one? Lamai, first one, velocity is decreasing. Wrong, no? Here, there is a 0 point and then increment. There is no 0 point here when you throw something down. See, there is a 0 point. Tell me, when something is thrown up, can there be a 0 point? Impossible. No. This is constant velocity. Guaranteed not constant velocity. Answer is this. Why not fourth one? Fourth one is constant velocity, Puta. Object won't be traveling with constant velocity. There is gravitational acceleration, not fourth one. So your answer is answer second one. Second, which is the correct velocity time graph for a fruit falling from a tree? Using your previous knowledge, tell me. Which one can be the answer? Which one can be the answer? Fruit falling from a tree. Fruit falling from a tree means it has an initial velocity or it's starting from rest. Falling from a tree means it's starting from rest. It's starting from rest. So guaranteed graph should start from 0 point. Constant acceleration is there, no? Guaranteed the graph will be like this. Not this, we never discuss about these types of graphs. We don't talk about curved graphs in VT graph. No? It comes in your displacement time graph. This curved graph you can't analyze in your level. Curved graphs or velocity time graph you can't analyze. Curved graph we only discuss for displacement time graph, not for velocity time graph. So answer is answer 2. Again I repeat, curved graphs are only for displacement time graph, not for velocity time. Velocity time, always flat lines we discuss. Third question. Which statement from the following correctly describes the motion of the object as shown in the graph? First analyze and tell me this is what kind of graph? What is this graph telling us? Velocity time graph. Graph is going down. Deceleration. This is guaranteed constant deceleration. Constant deceleration. Now read these points and see which one is constant deceleration. A hydrogen balloon at rest and projected upward. Think, hydrogen balloon going up. Hydrogen balloon will accelerate or decelerate? It will accelerate. You don't need to throw it. You just keep it like this. It will accelerate and go up. So this is wrong. Second one. A coconut detached from a stalk. Coconut from a stalk. Previous question we discussed. Fruit falling is acceleration. Something falling down is acceleration. Second one is also acceleration. Wrong. A train comes to rest from motion. On a train coming to rest is deceleration. That can be this. Train coming to rest can be this. Fourth one. A bottle rolling along an inclined plane. Lamai, tell me, if something is rolling down, what will happen? Accelerate or decelerate? Accelerate. You roll something down? Accelerate. So all the others are acceleration. Keep them in mind. Good question. Hydrogen balloon going up is acceleration. Coconut falling down is acceleration. Something rolling along inclined plane is acceleration. Something coming to rest is deceleration. So this is deceleration. Last question. Do. On. Now this question, we did it in essay as well. This type of question we did in essay. We converted displacement time graph to velocity time graph. Convert it. Same question I gave in my unit exam as well. Those who did the unit exam know the answer. First, analyze. The following displacement time graph shows the motion of Vimal who went to buy rice from a shop. We'll analyze the question. Displacement time graph is given. Displacement time flat line up. Displacement line flat line up is constant velocity. Displacement time flat line, straight flat line is object at rest. Displacement time graph is going down means again constant velocity but in opposite direction. And look at the timings. Here time is very short. Graph line will be short. Here time is very long compared to that. Graph is very long. Time is short, time is long. Now we'll convert it into a VT graph. I'll not look at the answer, I'll do it like essay question. We'll convert it. We'll slowly convert it into a VT graph. Velocity time. First part, constant velocity. But not a long time. Short time. Only how much of second? 5 seconds. 5. This is resting time period. Rest is here. Here constant velocity, opposite direction. So you draw in the positive side or negative side. Negative side. Line should be longer or shorter? Long. Go. Can't see, no. What's the answer? What is your answer? Tell me. Second. Okay. Finish. Today I timed it for 2 hours and made the things. Now tell me, is graphs hard? No, that's not. Very easy sections, right? Now I relieved your graph section. I did only some past papers. See that tonight itself, you all sit, take some more past papers, start doing some more question from this section and finish it. Few more questions. 2019, 20, some more questions are there. Take those essay questions and do. There's a question about ambulance. A nice question whether the ambulance driver can uh, save that person's life. Such a question is there. Recent past paper. Do that question. Some more past papers you take. Now don't ask me, sir, where to get the past paper. Go to internet and search. If you don't have a book, past paper, go to internet and search, download, take these questions and finish it off. Today itself, finish this graph section. Don't keep it again to study separately. Don't. And that is made easier for y'all from my end. So this is the first rapid revision free introductory section. If you want to join, you can join at Shakthi Institute, Bambalapitiya. Physically on Monday 2:30 to 5. Those are in and around Colombo. Try maximum to join to this one. Because physically I'll be observing whether you are working or not. If you're not working, I will squeeze you and make you work. So that is the physical class. And for outstation students, I'm doing it through Zoom online. Same Monday, I finish this and I come here. 7:30 to 10. Not on Tuesday, and this free class is going, today is Tuesday, but these classes will be on Monday, right? Those are the information, right? You can send a message to these numbers at the bottom. Hurry. That's the plan for today. Do we have any more free things? Yes, next week another free thing is coming. Power and energy of electrical appliances. We are doing it as a free online session. Next Tuesday and the following Tuesday. Next Tuesday and following Tuesday, power and energy free online session will be done. I'll update about that also to the group. Those are the main things. Marine, Hinang, keep working. Do these questions and finish it off. Now my input is given, your input is given. Finish it properly. Finish it properly, right? Again, go through this section, fully finish this lesson. If you can again take the book and go through the equations part. We didn't do much about the equation section. Go through the equation part and finish off this full lesson and keep it so that today this lesson, this part is done. Finish. Okay. Ehenang, last 5 months are there, less than 5 months are there. Don't stop working. Now it's the time for you to grind yourself, fully give your maximum of the maximum. You are never given such a potential out, such a output from you. Such a output should be given here. Work like robots, work like ghosts, go until the end point, finish it with the best result. Work. Now it's the time. Now it's the time for you. Don't just sit and burn your buttocks. Work. Give your full maximum of the maximum. Work with your maximum potential. You have never worked in your life like that. You have never given your maximum like that. You should go to the bed such that you feel sleepy. That way go to the bed. When you go to the bed, automatically eyes should close and you should feel sleepy. That way go to the bed. Don't go to the bed and start rolling here and there. No, then you can't call it a day. Your day finishes when you properly finish that day with your maximum potential. And today's potential is not tomorrow's potential. Tomorrow you go double that potential. Work. Bye.